So we're getting ready for a little quiz today. Overall, kids did really well, so don't be stressed. And here's the 2 points, 2 comma 7 and negative 3 comma 10. And I want you to tell me if it goes from this to that. It's got direction, as all parametrics do. Oh, wait, you can't see it yet. I am going to have you find a parametric description that goes between these 2 points. Giving you one more question to try, and then we'll grade both of these in just a second here. What if you had y equals 6x minus 5, but all I cared about was when it went from x equals 1 to, there's a lot of ways you can write these domains, x equals 7. That is all rectangular. It's part of a line. It goes from this to that. You should be able to make that into a parametric. So both of these are things that aren't parametric, and you're writing a parametric for them. Remember, a parametric goes as an x equals and a y equals, and it has to have a t is between this and this. All right, pausing while you try that one. Here's how you do that first one. You say x equals, and then y equals, and then you put the first point that you want, the 2 comma 7, you put that here. Then you talk about the change in x. X changed from 2 to negative 3. That went down, as in minus 5. And what else do you need in these x equations? A t. So it's got to have a t there. Raise your hand if you did that one right. Awesome. And then 7, and it went up 3 when it went from 7 to 10, plus 3t. Then I have to have a t thing. So the t thing is between what and what? Well, if I'm going to use t, I should pick it to be 0 and 1. There was no times before. I'm making stuff up. But if my t's, if I'm going to use this system, I have to use 0 and 1. Otherwise, this didn't ever have a time. It could have been at times 6 seconds, and this is times 7 seconds. But then my equation won't work the way I wrote it. The way I wrote it, it works perfect to use 0 to 1. Okay, this one, if I'm going to change it, you just say x equals t. You need an x equals equation, right? And it needs a t in it. And yeah, you actually could say it's t plus 1, but then it's going to be much more complicated to do this problem. If you stick to the system of just saying the simplest thing is x equals t, then you can say that this x needs to be changed to a t, and then everything's hunky-dory. I've got something that's in parametric, except it needs a limiter. And if you're ever going to do a sandwich like this where you've got the variable in the middle, then always use less than signs. Some kids don't know that, but it's a law in math. You cannot use greater than signs right there and there. They have to be less than signs. And then you put the smallest number on the left and the biggest number on the right. And there we go. And how do I know that t is x? Well, because I said so. I said x is t, so then these x's just become t's. T's goes from 1 to 7. Yes, sir?
Just curious. I noticed that. I'm curious because if you split it at the equal sign, you could have y equals t, and
it is interesting.
So could equal t then, but which do you think is better?
Okay, so let's talk about what this actually looks like in the real world. So if I graph this thing, the original, not the parametric one, but the original. The original equation was y equals 6x minus 5. Do you remember what that looks like? It starts at negative 5, has a slope of 6, and it's really steep. Does that ring a bell? Yeah. And it's only the part between 1 and 7 that I care about. So 1, which would have been at 1 comma 1 actually. How do I know that? Because if I put in 1 here, I'd get 1 there. You with me on that? Okay, it's from here up until 7, which is way up here, but it eventually stops. So it's only part of a line. You see what I mean? That's the part of the line that we're trying to write a parametric for. So as long as your equation recreates that line, if it's a straight line, there's an unlimited number of ways you could do this. I'm just trying to show you a way the lowest work. So if you've got another way, Zodi, I'm
No,
up for it.
I'm saying, I know that, but I'm wondering if which is better than the other.
I can't, that's a judgment statement. So I can just tell you that when I'm grading yours, I'm going to be looking for this way because it's the easiest. And if you also make me a different equation of x's and y's and t's that works, and then we're good. The only thing is that only really works for straight lines. If you're going to try to go off the books and try to do it some different way, it usually works if it's a straight line between 2 points. Because in the end, this is a point and this is a point, and it's just like that directed line segment thing, really. And so you can just, there's a lot of ways to do that kind. But if you have a curve involved, like for instance, let's say I said this, y equals x to the third plus 4x minus 7. And I said, change that over. Then that's got a curve in it, and you would not want to go off the books and try it some unusual way. You'd want to stick to the way I showed you, because otherwise it's very likely your curve might have the first point right and the last point right, but none of the points in the middle would work. If you do it the way I showed you, which is that x equals t, and then this is a t, and this is a t, and then I just had to figure out what the beginning and end were in the original problem, and figure out my t limit from that. That'll always work. Gotta stop because we still have a quiz to take, and we can talk more later if you want to. All right, so here's the next practice question, and this is not really a practice question. This is me trying to teach you a new thing today. There's only one thing left, and that's this that I'm about to teach you. And I'll also give you another chance to practice it tomorrow, because the test is really on Friday. This is just a little homework quiz that you're taking right now. It's counting as home. But, so pay attention, because this is not something you've done before. So imagine, for instance, that we have x equals 16 cosine of t. Would you agree this looks like it's setting up to be a parametric? And y equals 16 of sine of t. If I'm going to change this from being a parametric, and oh, one more thing, what do I need to be a parametric? A t. The t has to be between, let's say, 0 and pi. Okay. Now, the first thing I would want you to do in a problem like this is to be able to graph it. So, let's figure out what the TXY chart looks like. So far, there's nothing new here. But when I ask you to change it to rectangular, that's the part that you're going to be like, what? So for right now, you should be able to put in 0 and pi, but let's put in one thing in between. What's exactly between 0 and pi? Pi over 2. So find these 3 points. That one, and this one. And what I always do is I make a little XY chart, or sorry, this is the circle trig deal, and I go, this is 1, 0, because these are the quadrantals. They're a lot faster to find than having to draw triangles, but this is 0, 1, negative 1, 0, 0, negative 1. I'll pause for a second. Give that one a try. You're just graphing it right now. When you graph it, you don't graph it on that kind. You graph it over here. Because this only goes to 1, and yours will go a lot bigger than that. This was just to get your cosine of pi kind of things. When you graph it, take a new XY chart, or sorry, new X and Y axis. Okay, so you're starting with cosine of 0. That's to do this right here. So cosine of 0, that's the x value right in this point right here. The x value of that is 1. But it's times by 16. So 16 times 1 makes 16. On this next one, for the y value here, we're going to use this, and sine of 0, sine is the y, so that's 0. 16 times 0 is 0, so y equals 0. 16 comma 0, raise your hand if you had that one right. Okay, awesome. Now save me a bunch of time. Neil, would you tell me what you got for pi over 2?
0 for x and 16 for y.
0 comma 16. Okay, awesome. And how about pi?
Negative 16 and 0.
Excellent. Now would you please graph them if you haven't already? And remember, there's an arrow on your line because it starts at one place and it goes to another place. So graph those 3 points. So it starts at 0 at 16 comma 0. And then it goes to 0 comma 16. There's an arrow there. And then it goes to negative 16 comma 0. Look at that. It's kind of like a half a circle. So how many of you would have gotten the graph part right? Okay, cool. Then, next part. The next part is, can you change this over to only having x's and y's in it? Now, if you're trying to solve this for t, what you should be thinking is, well, then I'm going to solve this for t, and I'm going to solve this for t. But then you get, like, right away you're going to have to get into inverse and all kinds of weird things. So that ends up being pretty tough. So let me show you a way to solve both of these for t that's kind of outside the box. And you will need to know this, so pay attention. I am going to square both sides. Now, would you agree that I'm trying to get it to rectangular, so I want the x's and y's in it, so I'm just going to say I can add these two together as long as I add the others together. So x squared plus y squared equals the other two added together. I've got a calculator here. 16 times 16 is 256. So that's 256 cosine squared. I haven't left myself enough room to write. Gonna move this all over. X squared plus y squared equals 256 cosine t squared. And I know that seems like you're going the wrong way, but you're not. Plus 256 sine squared t. Now, if you're trying to get the t's alone so that you can get rid of them, who sees what we should do next? All right, for the 373rd time, we have a bunch of smart kids sitting here and nobody thinks of factoring out the 256. You might think of, well, why should I factor it? Because if you can factor it, you should. And then I bet you somebody's going to see it. As soon as I factor it, you'll see it. 256 cosine squared plus sine squared. Somebody's going to see it. I factored it. It's not about factoring anymore. But factoring brings you to this last step where you have a chance. Yes.
Isn't sine squared plus cosine squared 1?
Yes. Sine squared plus cosine squared is 1. That whole thing just turns into 1, which is pretty sweet. The t's are gone. Sine squared plus cosine squared is the same as cosine squared plus sine squared. It's 1. So x squared plus y squared is equal to 256, which happens to be 16 squared. I'm not really saying you have to write that, but isn't that make it look kind of nice? X squared plus y squared equals 16 squared. Isn't that the equation for a circle? Okay, but what's the problem with this? The problem with this is that we know that it's only supposed to be half of a circle. So this is where that domain and range thing comes in. So if we want this thing to only be the top part of a circle, then we would want to limit our y to only be from here to here. Because we only want the top half of the circle. Because otherwise, if I just say, I've got my answer, and it's x squared plus y squared equals 16, that's a circle that goes all the way around, and we only want it to be the top half of the circle. So again, when you're figuring out your limiter at the end, you got to go, well, what do I really want? I really only want this top half of the circle. I don't want this down here. And so if I set the domain, I'll end up getting the whole circle. So you got to set the range. Y would need to be between 0 and 16. Now, I know that was probably too much for some of you at the end there, but the main theme was square both sides, add it all up, factoring happens, you get a circle. Why can't I just leave the circle? Because I only wanted half a circle. So then I had to set something that would limit my circle so it would only be part of a circle, not the whole circle. Okay, I know that's probably too much. That's why on the quiz I'm about to give you, I'm giving you an extra credit question on that. If you can figure out what I just taught you on this quiz I'm about to give you, you get extra credit instead of just credit. The rest of the problems, those are all ones we practiced. So, all right, so that's all I have for the new stuff for today. The rest of the hour is a quiz, then you grade it. Then, for homework for tonight, you have some problems in the notes that have an answer key. You should do those and check them with the answer key. That's homework. That's what you do at home. And why would you want to do that? Because you have a test coming on Friday. And this is not super easy, and the test is coming quick. Yes, make it fast.
How do you know when to use y as a limiter other than x?
Okay, so if I had said x only goes from here to here, do you get I'd end up with the whole circle? So you have to look at the graph. If you look at the graph, you'll be able to tell. So if we do it a different way, where let's say we want only this part of the circle, we'd want to say, oh, well then I should say x goes from here to here, because that'll keep me, in the range that I want. Okay. All right, I know that's a stretch. I get it. That's why it's extra credit on the quiz I'm about to give you. Okay, so do some practice problems tonight. It's the notes. It's the only thing posted for today. It'll be easy to find it. And that's all I got for the video.